Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at calculating the area between two curves. So let's say I want to calculate this yellow area here. It's the area between the red and the blue curve. Well, it's actually pretty simple given what we already know. See, I know that if I want to calculate this whole area here between the curve and the x-axis, that's just going to be the integral, definite integral between a and b of f(x). Sorry, in case you can't read it, a is here and b is the point here. But then I need to subtract this area here, but this area here in black is just the integral between a and b of gx. So this gives us the formula for the area between two curves. It's just going to be fx minus gx. Now, one thing that's really cool about this is that when we're calculating the area between the curves, we don't need to worry about whether or not the curves are below the x-axis. And the reason is this. See, I could take this area here and simply move it below the x-axis. So I've still got the same x values a and b where they intersect. These two areas are the same. So it doesn't matter whether it's above or below the x-axis. I use the same formula here. So it doesn't matter whether one or both functions is above or below the x-axis. What does matter is that the greater function, the function with the greater y value, is first. And then you subtract the one with the lower y value. So fx is on top, so it goes first. Gx is on the bottom, so it's the one being subtracted. Now, unfortunately, sometimes you will have a case in which there's a function that's on top sometimes and on the bottoms at other times. So let's say I wanted to calculate the area between this red and this blue curve now. So what I'm really wanting to calculate is this area here plus this area here. So you can see in the first area, this region over here, the red function is on top. In this second area here, the blue function is on top. So what I'm going to need to do is I'm going to need to do each of these areas separately. So the first area is just going to be the integral of a to b fx minus gx. So I put fx first when I'm finding the area in this region here because fx is on top. And then what I'm going to need to do is add in this second area here. So this second area here goes from x equals b to x equals c, but this time in this area, the g, the blue function, is on top, so it goes first, and the function on the bottom is the one that I subtract. So again, we don't care if one or both functions falls below the x-axis. All we need to make sure is that the greater function, the function on top, is listed first. So in order to be able to do this properly, we need to know the points of intersection here, or at least the x values of the points of intersection. And remember, you can use your graphics calculator for that. You just graph both functions, you use the calculator function, and then go down to intersect. That option will tell you these values here, which are important. All right, that's all for this video. We'll go through some actual numerical calculations in the next video. Thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.